Hi everybody and welcome to HTTP in detail. Let's begin. What is HTTP or Hypertext Transfer Protocol? HTTP is what's used whenever you view a website developed by Tim Berners-Lee and his team between 1989 and 1991. HTTP is the set of rules used for communicating with web servers for the transmitting of web page data, whether that is HTML, images, videos, etc. What is HTTPS or Hypertext Transfer Protocol Secure? HTTPS is the secure version of HTTP. HTTPS data is encrypted, so it not only stops people from seeing the data you are receiving and sending, but it also gives you assurance that you're talking to the correct web server and not something impersonating it. So let's answer the questions. What does HTTP stand for? And that will be Hypertext Transfer Protocol. So let's type that in. Let's see, protocol like this, and we submit. Let me see, I spelled something wrong here. So hyper, there you go. Let's try again. Okay, and now what does the S in HTTPS stand for? And that will be secure. All right, and now on the mock web page on the right, there is an issue. Once you found it, click on it. What is the challenge flag? Okay, so let's find out. Okay, so let's take a look at the page here, and as we can see right here, the issue is that the site is not secure. It's using HTTP and not HTTPS, as we can see right here. So what we need to do is click on the padlock icon, and we'll get our flag, and there it is. So we can just copy the flag like this, click on OK, of course, and answer the last question of this task. So we paste the answer right here and we submit, and there you go. Okay, so let's move on to the next task, which is requests and responses. When we access a website, your browser will need to make requests to a web server for assets such as HTML, images, and download the responses. Before that, you need to tell the browser specifically how and where to access these resources. This is where URLs will help. What is a URL, or Uniform Resource Locator? If you've used the internet, you've used a URL before. A URL is predominantly an instruction on how to access a resource on the internet. The below image shows what a URL looks like with all of its features. It does not use all features in every request. Okay, so you guys can take a look at the image here with all of the features, and I'll read about them, okay? So first one, scheme. This instructs on what protocol to use for accessing the resource such as HTTP, HTTPS, and FTP, or File Transfer Protocol. User. Some services require authentication to log in. You can put a username and password into the URL to log in. Host. The domain name or IP address of the server you wish to access. Port. The port that you're going to connect to, usually 80 for HTTP and 443 for HTTPS, but this can be hosted on any port between 1 and 65,535. Path, the file name or location of the resource you are trying to access. Query string, extra bits of information that can be sent to the requested path. For example, /blog $ID = 1 would tell the blog path that you wish to receive the blog article with the ID of 1. Fragment. This is a reference to a location on the actual page requested. This is commonly used for pages with long content and can have a certain part of the page directly linked to it, so it is viewable to the user as soon as they access the page. Making a request. It's possible to make a request to a web server with just one line, like the one that we see right here, or right here. But for a much richer web experience, you need to send other data as well. This other data is sent in what is called headers, where headers contain extra information to give to the web server you're communicating with. But we'll go more into this in the header task. Okay. Example request. And here is the example that you guys can take a look at while I read about each line. Okay, so line 1, this request is sending the get method. More on this in the HTTP methods task. Request the homepage with / and telling the web server we are using HTTP protocol version 1.1. Then we have line 2. We tell the web server we want the website tryhackme.com. Line 3. We tell the web server we are using the Firefox version 87 browser. Line 4, we are telling the web server that the web page that referred us to this one is https / tryhackme.com. And then line 5, HTTP requests always end with a blank line to inform the web server that the request has finished. Okay. Example response, and here is the example that you guys can take a look at while I read about each line again. So line 1, HTTP 1.1 is the version of the HTTP protocol the server is using, and then followed by the HTTP status code, in this case 200 OK, which tells us the request has completed successfully. Line 2, this tells us the web server software and version number. Line 3, and the current date, time and time zone of the web server. Line 4, the content type header tells the client what sort of information is going to be sent, such as HTML, images, videos, PDF, XML. Then we have line 5. Content length tells the client how long the response is. This way we can confirm no data is missing. And then line 6, HTTP response contains a blank line to confirm the end of the HTTP response. And lines 7 to 14, the information that has been requested, in this instance the homepage. Okay, and now let's answer the questions below. What HTTP protocol is being used in the above example? And that will be HTTP. We can type that in, HTTP, and then we have / 1.1. Okay, and let's submit. All right, and what response header tells the browser how much data to expect? And that will be this one, which is content length. Okay, so let's type that in. So content length. There you go. And now let's move on to the next task, which is HTTP methods. HTTP methods are a way for the client to show their intended action when making an HTTP request. There are a lot of HTTP methods, but we'll cover the most common ones, although mostly you deal with the get and post method. Okay, let's begin with the first one. So get request. This is used for getting information from a web server. Then we have post request. This is used for submitting data to the web server and potentially creating new records. Then we have the put request. This is used for submitting data to a web server to update information. And then we have the delete request. This is used for deleting information or records from a web server. Okay, and now let's answer the questions. What method would be used to create a new user account? And that will be post method. So post. Okay, what method would be used to update your email address? And that will be put method. So we type in put. What method would be used to remove a picture you've uploaded to your account? And that will be delete method. Okay, and the final question, what method would be used to view a news article? And that will be get method. Oops, my bad. Get. And there you go. Okay, and now let's move on to the next task, which is HTTP status codes. Okay. HTTP status codes. In the previous task, you learned that when a HTTP server responds, the first line always contains a status code informing the client of the outcome of their request and also potentially how to handle it. These status codes can be broken down into 5 different ranges. Okay, so first we have 100 to 199. Information response. These are sent to tell the client the first part of their request has been accepted and they should continue sending the rest of their request. These codes are no longer very common. Then we have 200 to 299, success. This range of status codes is used to tell the client their request was successful. Then we have 300 to 399, redirection. These are used to redirect the client's request to another resource. This can be either to a different web page or a different website altogether. Then we have 400 to 499, client errors, used to inform the client that there was an error with their request. And then finally, we have 500 to 599 server errors. This is reserved for errors happening on the server side and usually indicate quite a major problem with the server handling the request. Okay, and now common HTTP status codes. There are a lot of different HTTP status codes, and that's not including the fact that applications can even define their own. We'll go over the most common HTTP responses you are likely to come across. And then first, we have, of course, the 200, okay. The request was completed successfully. Then we have 201, created. A resource has been created, for example, a new user or new blog post. Then we have 301, permanent redirect. This redirects the client's browser to a new web page or tells search engines that the page is moved somewhere else and to look there instead. Then we have 302, temporary redirect. Similar to the above permanent redirect, but as the name suggests, this is only a temporary change and it may change again in the near future. Then we have 400, which is bad request. This tells the browser that something was either wrong or missing in their request. This could sometimes be used if the web server resource that is being requested expected a certain parameter that the client didn't send. Then we have 401, not authorized. You're not currently allowed to view this resource until you have authorized with the web application, most commonly with a username and password. Then we have 403, forbidden. You do not have permission to view this resource whether you're logged in or not. Then we have 405, method not allowed. The resource does not allow this method request. For example, you send a GET request to the resource for creating an account when it was expecting a POST request instead. And then we have 404, page not found. The page or resource you requested does not exist. And then we have 500, internal service error. The server has encountered some kind of error with your request that it doesn't know how to handle properly. And finally, we have 503, service unavailable. This server cannot handle your request as it's either overloaded or down for maintenance. Okay, and click the View Side button on the right to see what some of these HTTP status messages look like in a browser, which everybody have probably seen, but let's check them out. Okay, so we have the 403 error, which we've probably seen, at least I have. The 404 error, of course, and the 503 error. So, yeah. That's that. So now let's answer the questions. So what response code might you receive if you've created a new user or blog post article? And that will be 201. Okay, now what response code might you receive if you've tried to access a page that doesn't exist? And that will be 404. So 404. What response code might you receive if the web server cannot access its database and the application crashes? And that will be 503. And finally, what response code might you receive if you try to edit your profile without logging in first? And that will be 401. Okay, and now let's move on to the next task, which is headers. Headers are additional bits of data you can send to the web server when making requests. Although no headers are strictly required when making a HTTP request, you'll find it difficult to view a website properly. Common request headers. These are headers that are sent from the client, usually your browser, to the server. Okay, so first we have host. Some web servers host multiple websites, so by providing the host headers, you can tell it which one you require. Otherwise, you'll just receive the default website for the server. Then we have user agent. This is your browser software and version number. Telling the web server your browser software helps it format the website properly for your browser. And also, some elements of HTML, JavaScript, and CSS are only available in certain browsers. Then we have content length. When sending data to a web server, such as in a form, the content length tells the web server how much data to expect in the web request. This way, the server can ensure it isn't missing any data. Then we have accept encoding. Tells the web server what types of compression methods the browser supports so the data can be made smaller for transmitting over the internet. And then we have cookie. Data sent to the server to help remember your information. See cookies task for more information. Okay, and now let's learn about some common response headers. These are the headers that are returned to the client from the server after a request. Okay, so first one, set cookie. Information to store which gets sent back to the web server on each request. See cookies task for more information. Then we have cache control. How long to store the content of the response in the browser's cache before it requests it again. Then we have content type. This tells the client what type of data is being returned. For example, HTML, CSS, JavaScript, images, PDF, video, etc. Using the content type header, the browser then knows how to process the data. And then we have content encoding. What method has been used to compress the data to make it smaller when sending it over the internet? Okay, and now let's answer the questions. What header tells the web server what browser is being used? And that will be user agent. What header tells the browser what type of data is being returned? And that will be content type. And the last question, what header tells the web server which website is being requested? And that will be host. Okay, and now let's move on to the next task, which is cookies. You've probably heard of cookies before. They're just a small piece of data that is stored on your computer. Cookies are saved when you receive a set cookie header from a web server. Then every further request you make, you'll send the cookie data back to the web server. Because HTTP is stateless, doesn't keep track of your previous requests, cookies can be used to remind the web server who you are, some personal settings for the website, or whether you've been to the website before. Let's take a look at this as an example HTTP request. Okay, so first, the client requests the web page from cookies.thm. Then the server responds back with a simple web page with a form asking for the user's name. Then the client sends back the form with the name set to Adam. The server responds with a set cookie header telling the client to save the data that we have right here, of course, the name Adam. Next, on the next and every further request, the client sends the cookie data back to the server. And finally, the server then sees the cookie data, and instead of displaying the form, it displays a welcome back message instead, which says welcome back, and then the data, which is Adam, right? Okay, so cookies can be used for many purposes, but are mostly commonly used for website authentication. The cookie value won't usually be a clear text string where you can see the password, but a token, unique secret code that isn't easily humanly guessable. Viewing your cookies. You can easily view what cookies your browser is sending to a website by using the developer tools, which we have in our browsers. If you're not sure how to get to the developer tools in your browser, click on the View Site button at the top of this task for a how-to guide. Once you have developer tools open, click on the Network tab. This tab will show you a list of all of the resources your browser has requested. You can click on each one to receive a detailed breakdown of the request and response. If your browser sends a cookie, you'll see these on the Cookies tab of the request. Okay, let's take a quick look. Okay, so here we have Firefox, or how to open the web developer tools in Firefox, in Chrome, in Safari, Edge, and Internet Explorer. But I think these images are a bit outdated. It's not a big difference, but let's compare Firefox because let's say this is what I'm currently using for this video. So you can see it's just a bit different. I have to actually go to more tools and then web developer tools. But in the image, we have to go to web developer first and then web developer tools. But it's not a big deal. You know what? If you use Firefox like me, if you are on Windows, just click on F12 on your keyboard. And yeah, you open the web developer tools this way instead. But yeah, so this is the network tab that they are talking about, or they asked us to open. We can just click on reload and we can see all of the resources here show up on the page. And yeah, you guys can actually, take a look at that yourselves. You don't need me for that. And I'll just continue to the next task. Okay. So let's see. Oh, okay, we have one question here. Which header is used to save cookies to your computer? And that will be set cookie. Okay, so set cookie like this. And we submit. And now we can continue to the last task, which is making requests. Click the View Site button on the right. This is an emulator for making demo HTTP requests. Using what you've learned from the above tasks, you can use it to complete the below questions. Okay, so make a GET request to /room. Okay, let's do that. Okay, so the first thing we need to do is choose the GET request, which is actually already chosen for us. So what we need to do here is just type room up here and click on go, and here is our answer, the flag that we see right here. So let's copy that and paste it right here and we submit. Then make a GET request to /blog, and using the gear icon, set the ID parameter to 1 in the URL field. Okay, no problem. So first we type in blog, and then we click on the gear icon, and let's set the ID parameter to 1. So we type in ID here and we type one right here, and we save that. We click on X, and then we click on Go. And there you go. Now we have our second flag that we can copy and paste right here, and we submit. And now make a delete request to /user/1. Okay. Again, we go up here, we type in user/1. We click on the gear icon and we remove the ID parameter, which we set to 1. Okay, so delete. And we click on X, and then we click on Go. Let me see, I think I forgot something, and that is, of course, to choose the delete request. Okay, so now it's going to work. Okay, so we click on Go, and there is our flag. Okay, so we copy that, and we paste, and we submit. There you go. Now make a put request to /user/2 with the username parameter set to admin. Okay, no problem. So again, we go up here, and the only thing we need to change is this. So we set it to, instead of 1, we set it to 2. And then we go to the up here, we click on the gear icon, and then we type in username. Let's see, username, and we're going to set it to admin, and we save it. Click on X, and then we click on first. Again, I must not forget, I have to choose my request, so I have to change it to the put request. I almost forgot once again, and now we can click on Go. Okay, and there you go. So now we have our flag down here, which we can again copy, and then we can paste it right here, and we submit, and we are correct once again. And now the last one, post the username of THM and a password of let me in to /login. Okay, so what you need to do here is just go up here, and then we just type in login. Okay, then we go back here, so we click on the gear icon. We can delete the parameter that we have here, the username parameter, which is set to admin. So we click on delete, and now we first type in username, and then the value is going to be THM, right? Okay, so we type in THM, and then we save that. And now let's create another parameter, which we are going to set to the key is going to be password, and the value is going to be let me in. Let's see, let me in, like this, and we save that. We click on the X button right here, and we click on of course post. Choose the request first, so which is the post request, and then we click on Go, and there you go. Now we have our last flag, which we can copy, and we paste it right here, and we submit, and we are done with this room. Okay, everybody, thank you for watching. If you enjoyed the video, found it helpful, please give it a thumbs up. I would really appreciate that. And of course, subscribe to the channel for more videos on TryHackMe. Okay, everybody, talk to you next time.